So first of all, a little bit of context. Here, the survey telescope are, as you can see here in the Paranal Observatory. One of them is in the platform, BST, very close to the UTs. And the other one, BST, is in a, sorry, Vista is in a different hill, very close, but still not close enough to just go over there. So, for example, that was one of the main challenge at the beginning, was how we address, let's say, this kind of remote operation if you compare the UT distance with the Vista telescope. Very practical example, how we decide to close the telescope if we have a weather problem, or how the weather officer can go there. And if you don't know, or you're not related with the weather officer is the TIO who actually decide when the observatory is open or closed due to weather conditions. And even though it's very close, you can have very different behaviors in Paranal and in the hill where is Vista. So we changed the procedures. We put some special tower there in order to address these kind of situations. So that was the first, let's say, issue that we had to address as a TIOs. And before that, before the service were there, we were driving or operate 4 UTs and 4 ATs. I will not go into many detail because most likely you already know all the details with the UTs. And these are or were the instruments that we need to drive during that time. So very demanding task. And for this, we in the department, we have roughly 25 astronomers, 17 fellows, 15 nighttime TIOs, 100% nighttime, and night operation specialists. 50% of their time they're doing day, and 50% of that time they're doing nighttime, and one senior executive assistant. So until that day, before the servers arrive, we have always 2 people in the console operating, the astronomer and the TIO. We used to operate in tandem. So basically you can share responsibilities and also you can share the time in the console. However, we started to change our model to this called Science 2.0 operation model, where an astronomer arrives at 3 p.m. and then she or he can leave the telescope at 2 or 4 a.m. Of course, that will depend in the conditions. It will depend if it's a visitor mode that is too complex for just living with the TIO and so on. But that was the main model. So we went from the 100% all-night astronomer TIO, then some part of the day with the astronomer, some part of the night astronomer and TIO, and then the rest of the night only TIO. So this is a summary of that. And the VLT operation will remain with 1 astronomer and 1 TIO all night. However, the survey telescope changed this because the plan was always to have only 1 TIO during the whole night. No astronomer will be there to do any support, and there's not going to be any visitor, at least that was the plan at the beginning, in the console. So all this responsibility to operate the telescope, the camera, doing the classification, checking the night logs, addressing the problems will rely with, in the TIO experience and the TIO knowledge. So we, as a group, we started to think and we're starting to see that this is quite new. And for the commissioning, you always have 1 person that actually 1 TIO that is an expert, you can say, or at the end of the commissioning, is an expert. But we need to share or give the knowledge to the rest of the team. And we realized that we were not being very efficient during that time to do that. So we create what we call it during the time the survey team, where economy was STEAM. So we create a mission. What was the STEAM mission of this? To standardize operation procedures, monitoring the night logs. The night logs during that time, around 2009, 2010, was a new tool that was being deployed and was tested in the survey telescope. Of course, was an old version using Remedy, but the transition from Remedy to the new tool that we have today was tested here in one of the missions of this STEAM group, was to check that that tool was performing well and the TIOs were learning how to use it, how to check if the NI is consistent, how to address the time loss, how to classify the time loss. Also supervise the training. If you have one new TIO arriving to the group, first they go to the UTs, and the way to operate UTs is quite different with the surveys. For example, the way that image quality or the way that the wavefront sensor works are different. UTs use Chart-Hartman. Vista, for example, use pre and post focal imaging and then correct these images using Cernic polynomials, which is not the same as within UT. So it's a small difference maybe, but in terms of operation looks different and the problems are different. And if you have these two systems working wrongly, or they are not performing well, the symptoms also are different. And the third point is working closely with the IoT coordinator in order to support the instrument scientists for all the tasks that he or she must address internally or outside. Then with the objectives, optimize the operation. That was the main goal of the STEAM group. Update the wiki, standardize the definition of the technical problems. As I mentioned before, we have a lot of knowledge in our database, in our problem reports regarding the ATs, regarding VLTI, and regarding the UTs. These two survey telescopes were new. We don't have previous information in terms of regular problems, in terms of how to address the problem. Sometimes we were not able to say this is a technical problem, it's a feature of the system, it's a problem created because how the OB was created. So we are starting to define how to report this kind of stuff in order to separate and create a workaround if it's needed, create a proper way to correct the problem if the problem was, let's say, OB or a science project that was not feasible. So we went to projects in order to address all these kind of issues. And finally, improve the communication into the group in order to share all the knowledge within the TIOs and the astronomers. Also, that part is important because the astronomers, since were not involved, except from the instrument scientists, in the operations, during the night, if we have a scientific question or maybe a gray area, the astronomers, for example, they're working in the VLTI, they didn't know how to address that because the knowledge was not, let's say, spread in a broad way. So this team, the idea was to overcome that miscommunication and giving some talks during the year in order to pass through to the rest of the departments. For example, one of the things that we developed, because one was a task that we need to perform as a TIO, is to grade the data. And as you know, since you're using all the surveys products, 16 chips or 32 chips in order to see how is the quality, it's very hard to do it if you're doing visually. So at the beginning of the operations, as a TIO, we were checking chip by chip how the quality of the image was. This is giving two problems. It's very complex to realign your eye. You don't have a statistic, let's say, measurement that you can say, okay, I'm doing 90% or 100% of the targets because it would be impossible. It's giving you a bottleneck because you are taking too much time in order to grade. And you must also certify that the data is correct. So what we did, we create this what we call a quality control operation panel. And here you can see how we were grading the OBs. So you can see if it's A, B, or C, and why. So we extract this data from the pipeline, and we create this script in order to save this all of this data. Also was very useful because, for example, we can recreate the night, and we can say, for example, if an API is concerned about whatever grading, we can go back in time and see, okay, this was grade B because of this constraint was out. Or, for example, when we were into the operations, some rules of classification change because they have long OBs, some concatenation OBs, short OBs, 20 OBs from concatenations. So in order to be more efficient, we put all the rules within the script, and now the TIO only needs to check this OB, this panel, see the grade, check visually with one or two images from the data itself, and certify that the data is right or not. But with this case, we save a lot of time. So after this, we're starting to see if we can optimize the operation in the surveys. And we realized that it was possible following maybe some kind of optimization projects, but it was possible. So the idea was to put one TIO driving both surveys. Vista and VST, they're quite similar in terms of operation, even though their two are not so similar with the UTs. But we thought during the time it was possible to put one operator driving both, as the original plan was supposed to. And since we're going to have some challenge in terms of Paranal observatory and for LGSF, more complex system, adaptive optics system, M2 with adaptive optics inside. So we wanted to have one more FT to go to these kind of systems, also go to VLTI, and have more flexibility within those systems, and having one TIO with everything working smoothly into the service. So we made a study, and our conclusion was basically that we have to automatize some process, some improvements in some panels operations. We have to do a redistribution of the consoles, create more robust startup and shutdown scripts, and a new location for the Vista anemometers in order to also have a strong measurement about the wind in the Vista telescope. So for us as a group, as a TIO group, we saw this as a great opportunity to grow and to show that we were capable to start from one point and go to forward. So in terms of thermal automatization, now everything is automatic. For example, VST was delivered with the wind screens manually deployed. So you can have a very low target, and if you as a TIO forget to remove the windscreen, you will be netting because the system will don't know that the windscreen is in the line of sight of the telescope. So we as a group, we fixed this, and now all the windscreens, all the air conditioning, everything is automatic. The ventilation doors, all of that. So also that creates a good way to remove the dome sync, because previously, if we were not opening manually and it was more intuitive, you will have very bad image quality, not because outside was a bad environment condition, was inside, because we were not removing the air. So now we also see the ergonomic part, how we change from one side to another. So we will remove all these screens and put all together in one side of the console. We have plenty of panels that it was showing how how we should address some conditions or some variables from the telescopes. And when we made a study and we integrate everything in one in order to have the log monitor visible all the time and concentrate all the information from the thermal, from the telescope, and from the M1 in one single place. This is the OT3 that we were using during that time, how we use it. However, we had some problems, not with the OTs, with some variables that we need to address in terms of constraints. So we create several scripts that were showing us if the flags were done properly, it will have the controllers synchronized, because, for example, Vista has 16 chips, but it's divided in 8 and 8. So you have two controllers, and if those controllers are not synchronized 100%, you will have the first half of the chip saying, I'm done, and the telescope will move. And the second part of the array will still integrating. So you can have a huge ellipticity because this mismatch of time. So the first script on the left with green letters is telling us during the night basics that these controllers are fine. If their controllers are not properly synchronized, they will give us an alert and we can call to the person that will fix the problem. And the rest is, for example, if it's a problem with the pipeline and it's not being reduced, the data, you have the raw data, and the raw data will be cross-correlated with the SIM in the ASM, and we'll see if it's consistent or not in order to classify. After the same class project finished, we were capable to do all the optimizations, and we were capable to start the dry run. The dry run was 6 months long, and we delivered a final product with one single TIO driving both telescope in one half of the console with everything integrated, without compromise the quality of the data. Also, that was very important. Was one of course, when you optimize something, you want to maintain the same quality or improve the quality. So we didn't lose any kind of quality of the data. Then I'm going to go a little bit in terms of the reporting experience, because as I said before, these problems were quite new. We didn't have all the parameters quite well characterized, and we were facing issues that we have never seen before, let's say in the UTs. So we're starting to have problems with the wavefront sensors, with some cycloid executions. I will not go into the details, but these kind of things were, even though the names of the process are similar to the other ones, the root cause were totally different. We have electricity sources, and this was one of the problems that we had to address. And it was very hard to realize which system or what thing was causing the electricity. One of the main things were the M2 corrections, the axis oscillations, and the AO corrections. And when the AO were applied while the telescope was moving or while the telescope was integrating. And another definition was, is this a propagation loss? If we have two guide stars, or is a problem of the catalog, or what was happening? The VST, same stuff. In the M2 also was giving a lot of issues, a lot of problems, was no solution at some point. The rotator went to standby. We didn't know why. The rotator had an interlock. We didn't realize at that time what was the root cause of the issue. So we say, okay, we are having the same stuff in terms of electricity in VST and the survey. and the Vista. So we say, you know what? We need to standardize how we collect the data and how we report this, because for the engineerings, it will be so much easier to understand the problem is all the DIOs report the same thing exactly as the engineer needed. So this sounds a little bit obvious that we always need to be reporting in the same way. However, for example, if the title change for the engineering, maybe it's not the same problem that it was discussed 2 days ago. And see, we are having this chief condition, the chief change, and if you see the title of the ticket, the title of the problem maybe can give you a bad idea or not the good idea what is the problem. So we create these macros and this panel in order to collect all the information what that was happening during the problem. This is the old tool that we used to do. We create a macros in order to create always the same title, always the same location, the same system, subsystem assigned to the group that was discussed with the engineering team, who is going to address first this kind of issue. And at the end, we were giving something like that. A lot of parameters, the time lost, the timestamp, which is very important. I would say is maybe the most important thing is the timestamp, what happened, how much time did we lose. However, we had problem with this procedure because we had problem with the timestamp. When you have a problem in the console, the natural reaction of the TIO is not to press a button to record data. It's just trying to fix the problem, trying to address what's happening, and trying to recover the system as soon as is possible in order to keep doing the observation. So another problem was the remedy was updated, so we didn't have this kind of tool anymore. Now it's a Jira ticket, and the macros were not available, and some software updates within the TCS, and also our way to collect the data was not longer feasible. So we changed our strategy, and we're starting to use a new structure, and there is the data lab. We created with engineering some scripts that will be saved and locked within this new structure. You can be more selective in terms of you can put the time that you want to see, when it starts, when it ends, and you will see everything in terms of logs and information. Also, we discussed with engineering team, besides the parameters, what do you like to see? You like to see something visual? You want to see if the axis is oscillating, you want to see the curve? What do you want? So we have all this information, we collect all together, and we're starting to create these Jupyter notebooks. So you can run it during the night. Every time that you have a problem, you will see the nature of the problem. You can perform the workaround, or you can call the expert, and also there will be all this information will be attached to the ticket in order to pass the information to the system, to all people involved, and you will be also being capable to fix issues in a, let's say, in a fast way. This is one example of how you can have all together. You can have here the axis. You can have of course, maybe you will not understand the graphic, which makes sense. But here you can see the altitude, the axis, the M2, the M1, and how it's behaving, is guiding or not with the error that you are looking for. And here you can have also the report with all the information together. If you have electricity, you can see here how is the behavior, and with these plots, you will understand what is the root cause. And for example, in this case was a small oscillation, and you can see that. And now we know that the electricity was because of this oscillation. So basically, one of the lessons learned, or we can say one of the lessons learned is the survey telescope changed the operational concept, but we as a group, we understood this and we were capable to address this change, and we, let's say, capable to overcome the challenge. We had to create an expert profile, or we have to create a specific team in order to optimize operations. And also the time gave the experience that there was a very good idea. So we take that for the next challenge. Also, we create, for example, for the 4LGSF, a specific group within the TIOs in order to learn from the 4LGSF AO in a very deep way in order to pass the information within our group. The continuous improvement that we had when we create this project and we optimize the way that the service operates also is going to be applied in some way to the UTs, and also was applied for the VLTI in terms of the 80s observations. And the script for reporting and classification, I would say at some points were the key to the optimization of operations. And also that is being used as a lesson for the rest of the UTs. Now we are developed, there's a, let's say, it's called Scuba, a software that is giving all this information for different instruments, and is being used to classify, to check the data quality. But all of this is coming, I would say, from this first step that the surface telescope gave us as an opportunity to be hands-on of this, to learn about this, see how it was the outcome. The quality didn't change, so we were capable to take the risk and go a little bit forward. That will be it. Thank you very much.